All right. This will just be a quick little video kind of going through how we translate English phrases into mathematical statements and into mathematical inequalities in particular. This is going to be helpful for us as we move into talking about probability distributions in section 2.5. So, this chart here on the left contains a bunch of really common phrases and their transition into, or their translation into math. So, for example, if you see something that says some quantity is less than or equal to 7, then this would be the way that we would encode that mathematically, right? We would say x is less than or equal to 7. To say x does not exceed 7, right? That means that x could be as much as 7, but not more than that, right? So x would have to be less than or equal to 7, and so forth. I'm not going to read each one of these things to you, but if you take some time and think about them, it should make some sense why we translate certain phrases into their corresponding math symbols. What I want to do is just go through several examples of this, and that's all we're going to do in this little support section. So number 1 here says, translate each statement into math symbols. Use X to represent the quantity being described, and use a capital P for probability. Okay, so part A says, my car gets more than 25 miles per gallon. So we're going to use X to represent the number of miles per gallon that my car gets. And we're told that it gets more than 25 miles per gallon. So we would encode that as X is greater than 25. Okay? And by the way, as I'm going through these, you should pause the video and see if you can answer these questions on your own. But let's look at part B. It says, my car gets no more than 25 miles per gallon. So again, we're going to use X to represent the miles per gallon that my car gets. If it gets no more than 25 miles per gallon, then that means 25 miles per gallon is the maximum that it gets, right? So the miles per gallon that my car gets, X, has to be something less than that, or possibly something equal to it, but not more than it, right? So X would have to be less than or equal to 25. Okay, part C. That goat weighs at least 15 pounds. Okay, at least 15. That would mean that the weight of the goat, X, is 15 or more, because it weighs at least 15 pounds. So it would have to be greater than or equal to 15. Okay, part D. That goat weighs less than 15 pounds. Well, okay, so clearly we would just say X is less than 15. All right, let's throw some probabilities into the mix, okay, because this is the context in which we're actually going to see these kinds of things. So part E says, what is the probability that at most 10 people will run for governor? Okay, so we want to find the probability that at most 10 people. So let's say that X is the number of people that run for governor. We want to know the probability that X is at most 10. Right? At most 10. So that means that X could be 10, or it could be something less than that, but it can't be more than 10 because it's at most 10. So X would be less than or equal to 10. Okay, that's how we would encode that probability. Part F. The probability that fewer than 7 cell phones are defective is 0.752. So now they're actually giving us the answer, right? They're saying that the probability in question here is 0.752. Well, let's see how we would encode this mathematically. So we're wanting the probability P, okay, that fewer than 7 cell phones are defective. So let's say that X is the number of cell phones that are defective. We want to know the probability that X is fewer than 7, right? Less than 7. And then we're told what the answer is. We're told that, well, the probability that fewer than 7 phones are defective, in other words, the probability that X is less than 7, is 0.752. So that's how we would translate that statement into math. Part G. Find the probability that the proportion of people who think Batman is real exceeds 0.07. Okay, so we want to find the probability that the proportion of people who think Batman is real. Let's say that X represents the proportion of people who think Batman is real. We want to find the probability that the proportion of people who think Batman is real exceeds 0.07. So we want to know the probability that X exceeds 0.7, that X is greater than 0.07. Okay, and one more. Part H says there is a 0.138 probability that no fewer than, that should say than, that no fewer than 17 inches of rain will fall tomorrow. Okay, so there is a certain, so it looks like here they're giving us the answer again. They're telling us what the probability in question is. They're saying it's equal to 0.138. But what is the probability they're describing, right? They're describing the probability that no fewer than 17 inches of rain will fall tomorrow. So the probability that no fewer than 17 inches. So let's say that X is the number of inches of rain that will fall tomorrow. We want the probability that X is no fewer than 17. Okay, so it could be 17 or it could be something more than that, but it can't be fewer than that, right? So no fewer than 17 would mean greater than or equal to 17. We're told that the probability that X is no fewer than 17 is 0.138. And so that's how we would translate that statement into math. And that's that. You'll have some opportunity to practice this in the corresponding support assignment here. But for now, that's all I have to say. And don't forget to come back to this chart if you get stumped by something. And really just think through these phrases and make sure that you understand why they're being translated the way that they are. And that'll do it for now.